Problem set 5. Stopping a bullet. A bullet of mass traveling horizontally with speed hits a block of mass that is originally at rest and becomes embedded in the block after the collision. The blocks slide horizontally a distance on a surface with friction and then falls off the surface at a height, as shown. The coefficient of the kinetic friction between the block and the surface assume the collision is nearly instantaneous, and all distances are large compared to the size of the block. Neglect air resistance. So, in this problem, we are asked to find the minimum speed of the bullet so that after colliding with the block, the combine of the bullet and the block will just reach the edge of the table before stopping. To understand this, we must look at the motion in two stages, the collision and the sliding. So, when the bullet of mass strikes the block of mass, it becomes embedded inside the block. So, since the collision is perfectly inelastic, momentum is conserved. This means the total momentum before and after the collision must be equal. Before the collision, only the bullet has momentum. After the collision, the bullet and the block move together as one system. From this principle, we find the velocity of the system right after the collision. V is equal to the bullet's momentum divided by the total mass of both the bullet and the block. This shows that the block and bullet move with much smaller velocity than the bullet originally had, because the mass is larger when they stick together. Once the block and bullet begin sliding, friction acts on them and gradually reduces their speed. The work done by friction depends on the frictional force and the distance traveled, which in this case is the distance from the collision point to the edge of the table. So, the frictional force is equal to the coefficient of kinetic friction multiplied by the total weight of the bullet and block system. The total weight is the combined mass of the bullet and the block multiplied by gravity. And the work done by friction is equal to the coefficient of the kinetic friction multiplied by the total mass multiplied by the acceleration due to gravity and multiplied by the distance of the surface. And for the system to just make it to the edge, the initial kinetic energy of the bullet block system must be exactly equal to the work done by friction. So the kinetic energy equals 1/2 times the total mass multiplied by the square of the velocity after collision is So the kinetic energy equals 1/2 times the total mass multiplied by the square of the velocity after collision. This also equal to 1 half times the square of the bullet mass multiplied by the square of initial speed divided by the sum of the bullet mass and the block mass. If the kinetic energy is less, the system will stop before reaching the edge. If it is more, the system will reach the edge with leftover speed. So by setting the kinetic energy after the collision equal to the work done by friction, we can solve for the minimum initial speed of the bullet. So the minimum bullet speed is equals the sum of the bullet's mass and the block mass divided by the bullet's mass multiplied by the square root of 2 times the coefficient of kinetic friction times gravity and times the distance. So, the result shows that the required speed depends on the total mass of the system, the bullet's mass, the coefficient of friction, the gravity, and the distance of the edge of the table. In short, the bullet must have enough speed so that its transferred energy can overcome the resistive force of friction, allowing the block and bullet to just reach the edge. So that's all for letter A.
So here is the question for letter B. Assume that the initial speed of bullet U is large enough for the block to fall off the surface. Calculate x sub f, the position where the block hits the ground measured from the bottom edge of the surface. Express your answer in terms of some or all of the following: m sub 1, m sub 2, u sub mu sub k, u, d, h, and g. So here is the solution. First step is to determine the velocity after collision, given by v equals m sub 1 times u over m sub 1 plus m sub 2. So that's the first formula was given by. Then next step is velocity after sliding. So we have given by work energy theorem. So this is the work energy theorem. 1 half m sub 1 I multiply by m sub 1 plus m sub 2 times v squared sub f minus 1 half multiply by m sub 1 plus m sub 2 v multiply and v squared. So equal to negative mu sub k multiply by m sub 1 plus m sub 2 times g d, and v v squared sub f equals v squared minus 2 mu sub k gd. Then v squared sub f equals m sub 1 u over m sub 1 plus m sub 2 squared minus 2 mu sub k gd. Then then we have to square that, and this para mawala na ni para makancel ni siya. So this is the final, the v sub f equals square root of m sub 1 times u over m sub 1 plus m sub 2 squared minus 2 mu sub k g times d. Next is to determine the projectile motion. The block falls off the table with horizontal velocity v sub f, given by time to fall t equals square root 2h over g. So this is the formula of determining calculating the t, square root of 2h over g. Then horizontal distance x sub f equals v sub f times t. So this is the horizontal distance. Next is to determine the final expression. Next is to determine the final expression. X sub f equals square root of 2h over g multiplied by square root of m sub 1 multiplied by u over m sub 1 plus m sub 2 squared minus 2 mu sub k g times d. Then since the same naman sila, so itapo na sila to get the final expression. So x sub f equals square root of 2h, tapo na sila, over g, tapo dayon parenthesis, bracket, parenthesis, m sub 1 multiplied by u over m sub 1 plus m sub 2 squared minus 2 mu sub k gd. Then bracket. So therefore our final expression is calculating the x sub f. This is the final x sub f is equal to square root of 2h over g, bracket, parenthesis, m sub 1 multiplied by u over m sub 1 plus m sub 2 squared minus 2 mu sub k g times d. So this is the final formula to in expressing your in terms of some or all of the following: m sub 1, m sub 2, mu sub k, u, d, h, and g. So this is the final expression of calculating x sub f. Thank you.